Hello everyone, I'm Stefano Cursi. Sorry for not being present today, but I'm happy to be able to contribute remotely. I am a researcher at the Institute of Heritage Science of the National Council of Research, which is an interdisciplinary institute whose mission is to pursue scientific excellence and encourage innovation in the understanding of conservation and enhancement of cultural heritage, with over 180 researchers, technologists, and technicians from various disciplines. This is the current staff of the Built Heritage Innovation Lab research group, coordinated by the researcher Elena Gigliarelli, which is composed mainly of architects and engineers. And our group works in developing and applying digital methodologies and technologies to the knowledge and documentation of historic buildings, paying particular attention to the analysis of the building techniques, but also to the acquisition of information related to the entire life cycle of the building. And these are the main areas of intervention of the lab, ranging from diagnostic and protection analysis to conservation processes, knowledge management, but also energy and environmental improvement and museum and archaeological site design. Inside DARIAH, we want to start a discussion about the theme of the digitalization of built heritage to build a main point of contact for architects and experienced conservators and researchers interested in implementing digital-based methodologies and strategies for information models that can represent the uniqueness of our architectural heritage and its historical, artistic, and technological components. Through research, workshops, and collaboration with other DARIAH working groups, we would like to work to address best guidelines and practices for managing open data with semantics, spatial, and temporal subsets through the development of a sort of pan-European virtual lab aimed at offering services and resources for data representation and management. This digital resource will enable interdisciplinary exchange and interoperability, as well as promote a culture of data sharing regarding the permanences and mutations of common architectural typologies built over the centuries in Europe and their inclusion in modern society. This idea comes from the fact that in the context of building processes concerning the investigation and conservation and management of built heritage, the complex preliminary phase of study and documentation of a given building is characterized by heterogeneous qualitative and quantitative data. This profoundly affects all proposals and actions taken by the different specialists involved with their related processes and needs. Therefore, any gaps, inconsistencies, or misinterpretation of the data successively may lead to wrong decision in a phase of intervention with consequent damage to the artifact. Thus, knowledge representation and management has always been one of the most challenging topics for the heritage industry, both in terms of documentation and accessibility. However, the processes concerning the study and documentation of built heritage are still generally managed through a document-based approach that is directly derived from the traditional bibliographic one. One proposal may be to create a digital inventory within which it's possible to integrate all this knowledge. This would allow for a repository where data can be stored and organized even when not directly attributable to building objects. In general, this approach can have many positive effects on the process regarding the built heritage. In particular, those are the benefits that we believe are the most important for this project. So, having a unique archive of data, support collaboration among specialists, and having this knowledge represented will allow the querying of this knowledge. One viable venue is the one of building information modeling. Today, the application of building processes in the cultural heritage sector has focused mainly on digital documentation of buildings, fueled by technological developments and three-dimensional data acquisition. The HBIM processes, on the other hand, lend itself to integrating the management and production of information through the life cycle of property into a centralized, efficient, consistent, and non-redundant system. Each HBIM represents a dense case of knowledge, so it's a drop in the ocean represented by monuments and building systems around the world, with little accessibility to a larger audience and no cross relationship with other similar libraries. HBIM can feed the digital inventory we want to develop within a spatial and temporal structure. This is a representation of the methodology we use when tackling HB modeling of a historic building. We start with the analysis of the assets left of the diagram, in which we collect both geometric and informational data, and all of this data is then pivoted through digitalization protocol into the geometric and semantic rendering of the building. So within the HB methodology, it is possible to integrate a whole series of inputs within a federation of models that concerns geometric survey, multidisciplinary analysis, simulations, design and maintenance activities. In this area is often used the scan-to-bin method, which starts with an integrated geometric survey, so integrating laser scanners, LAM, photogrammetry, from which point cloud is derived, which is then used as a scaffold for the construction of the buildings. These manual processes has its own great usefulness for building knowledge, because it allows us to delve into the construction systems used, the building modularities and patterns, as well as also its irregularities, which are often clues to some historical phase or particularity of the building that in a fully automatic processes, when one day it will be made possible by technological evolution, often might be lost otherwise. Of particular importance is the decomposition of the building into building elements and spaces that allows this to be traced back to BIM object classes. Such work is essential for a solid and reliable structuring of the database, with data in the BIM environment are related to the model objects. The results and experiences of the projects that we have dealt with during these years have consolidated in us the conviction that there is a need to systematically survey and order a specific body of knowledge in the field of historical building techniques, the loss of which otherwise can be traced back to the waning of crafts of traditional making. So the unavoidable purpose appears to be to record the various expressions of local history and tradition and technical culture that European cultures have been able to express over centuries of building activities. Another way to produce and share knowledge on historical construction techniques is the study from an energetic and environmental point of view of historical buildings and settlements that can also be carried out using the digital tools of numerical simulations. So in this case, the analysis aims to verify the effectiveness of an ancient settlement principles for both documentation and conservation purposes, and also for guidance for the new construction. Here you see also the integration of a BIM environment with an artifact-specific ontological knowledge base that aims to provide a solution that fully covers the knowledge produced in our heritage processes needed for its documentation and shared among the specialists involved in the process. By integrating ontologies and building information modeling, it is possible to enrich the semantics of the representation, including, for example, the relationships between different structural components of the building in its evolving configuration. So, with ontologies we can represent different knowledge domains pertaining to tangible or intangible knowledge, direct or indirect knowledge. So, heterogeneous knowledge sources that can be shared among specialists. So I hope the topic was interesting, and thank you for your attention.